Hi to everyone. Today I would like to discuss about ionization energy. Ionization energy is the minimum energy required to remove an electron from a gaseous atom or ion in its ground state. The unit that we use for ionization energy is kilojoule per mole. Ionization energy can be divided into two: the first ionization energy and the second ionization energy. So, the first ionization energy is defined as the minimum energy required to remove one electron from the outermost orbital of a neutral gaseous atom in its ground state. Example, sodium atom becomes sodium plus electron. The second ionization energy is defined as the energy required to remove one electron from a positive gaseous ion in its ground state. Example, sodium ion becomes sodium ion with 2 plus electron. So let's check out the tutorial question 7. What is meant by the first and second ionization energies? The first ionization energy is the minimum energy required to remove one electron from the outermost orbital of a neutral gaseous atom in its ground state. The second ionization energy is the energy required to move one electron from a positive gaseous ion in its ground state. While B state the factors that affect the ionization energy of an atom. The factors that affects the ionization energy of an atom is atomic radius, effective nuclear charge, and screening effect. Tutorial question 9. Ionization energy for nitrogen atom is greater than that of oxygen atom, but the ionization energy for nitrogen ion is lower than oxygen ion. Explain. So, nitrogen atom and oxygen atom under first ionization energy. Ionization energy of nitrogen atom is greater than oxygen atom because of electronic configuration of nitrogen is 1s2, 2s2, 2p3, which is half filled 2p orbital, while oxygen is 1s square, 2s square, 2p4, which is partially filled 2p orbital. Thus, half filled 2p orbital of nitrogen atom is more stable than partially filled 2p orbital of oxygen atom. So, more energy is required to remove an electron from a more stable half-filled 2p orbital of nitrogen. Therefore, ionization energy of nitrogen atom is higher than oxygen atom. Nitrogen ion and oxygen ion under second ionization energy. So, ionization energy of oxygen ion is greater than nitrogen ion because of the electronic configuration number. Nitrogen ion is 1s square, 1s2, 2s2, 2p2, which is partially filled 2p orbital, while oxygen ion is 1s2, 2s2, 2p3, which is half filled 2p orbital, which is more stable. Thus, half-filled 2p orbital of oxygen ion is more stable than partially filled 2p orbital of nitrogen ion. So, more energy is required to remove one electron from a more stable half-filled 2p orbital of oxygen ion. Therefore, ionization energy of oxygen ion is higher than the nitrogen ion. That's all. Thank you.
Element M will form ion with a charge of positive 1 because the ionization energy is increasing accordingly. Element K and element L belong to the same group because the difference between ionization energy 5 and ionization energy 4 is the highest for both elements. The first ionization energy values for the two elements is: the first ionization energy for element L is lower than K because L is in lower period than K. The atomic size of L is bigger and the screening effect is greater than K. Thus, the attraction of nucleus on the outer electron is weaker. Element L is group 14 because The outer shell has donated one electron to the inner shell. Therefore, from having 5 electrons becoming 4 electrons. So when 4 electrons must plus with 10, it becomes group 14.
Hi all, today we are going to learn about anomalous cases. Before that, what is the meaning of anomalous? So, let's continue with anomalous cases of ionization energy. The increase of ionization energy with proton number is not uniform. In period 2, there are two cases. Group 2 with group 13, which is the element is beryllium and boron, and group 15 with group 16, the element is nitrogen and oxygen. Next, in period 3, there are two cases, which is group 2 with group 13, the element is magnesium and aluminium, and group 15 and with group 16, the element is phosphorus and sulfur. This table shows the variation of the first ionization energy across period 2. From this table, we can conclude that the ionization energy are increased except for group 2 and 15. This is the variation of the first ionization energy across period 3. From this table, we can conclude that the ionization energy across period 3 are increased except for group 2 and 15. This graph, kilojoule per mole against proton number, shows that the variation of the first ionization energy across period 2 and period 3. Element that contains the highest first ionization energy for period 2 is neon and period 3 is argon. Next, we look for anomalous cases for beryllium and boron. Between beryllium and boron, the first ionization energy of beryllium is greater than boron. This is because the electron in 2p orbital of boron is at higher energy level than 2s electron in beryllium. The attraction between the nucleus and 2p electron is weak. So, less energy is needed to remove the 2p electron. Therefore, ionization energy of boron is lower than beryllium. Besides that, more energy is required to remove electron from a full filled 2s orbital in beryllium, which is more stable. So, beryllium has higher first ionization energy than boron. Then, the anomalous cases between magnesium and aluminium. The first ionization energy of magnesium is greater than aluminium. The electron in the 3p orbital of aluminium is at higher energy level than 3s electron in magnesium. The attraction of nucleus toward the 3p electron is weaker. So, less energy is needed to remove a single 3p electron in aluminium than to remove a pair 3s electron in magnesium. Therefore, ionization energy of aluminium is lower than magnesium. Besides that, more energy is required to remove electron from a full filled 3s orbital in magnesium, which is more stable. So, magnesium has higher first ionization energy than aluminium. Next, we look for anomalous gases for nitrogen and oxygen. The first ionization energy of nitrogen is greater than oxygen. This is because the half-filled 2p orbital of nitrogen is more stable than partially filled 2p orbital of oxygen. So, more energy is needed to remove the first electron from nitrogen. More energy is required to remove an electron from a stable half-filled 2p orbital of nitrogen because it also makes the atom less stable. Therefore, the ionization energy of nitrogen is higher than oxygen. This is the SPDF notation and orbital diagram for nitrogen and oxygen, which is the half-filled of 2p orbital for nitrogen and oxygen is 2p orbital partially filled with electron. The last anomalous cases is between phosphorus and sulfur. The first ionization energy of phosphorus is greater than sulfur. It is because the electronic configuration of half-filled 3p orbital of phosphorus is more stable than partially filled 3p orbital of sulfur. So, more energy is needed to remove the first electron from phosphorus. More energy is required to remove an electron from a more stable half-filled 3p orbital of phosphorus, and this will cause the atom less stable. Therefore, the ionization energy of phosphorus is higher than sulfur. This is the SPDF notation and orbital diagram for element phosphorus and sulfur, which is the phosphorus is half-filled 3p orbital and sulfur is 3p orbital with partially filled with electron.
I hope you enjoyed this video. Thank you.